Okay, so in this video, we're going to look at a different type of sequence. These are geometric sequences. So in general, a geometric sequence doesn't go up by the same amount each time like an arithmetic sequence, but we have some common multiplier that we use instead. So a good example would be 2, 4, 8, 16, 32, and so on. As you can see, then there is no common difference, right? But instead, what we have is a common ratio, and that is the number that we multiply by to get to the next term. So clearly you can see in this particular example, we call it R, the common ratio. R is 2. Again, it's the same other notation as before. U1 in this case is 2. U4, for example, is 16. All right, it makes no difference. Now, what about if I had something a little different? So, for example, 81, 27, 9, 3, 1, a third. You get the idea, okay? Is that geometric? Well, yes, it is, okay? And what is the common difference this time? R is a third. I multiply 81 by a third to get 27. By a third, 27 to get 9. By a third from 9 to get 3, and so on and so on and so on. So in this case, R is 13, a third, and U1 in this case is 81 again, for example. Okay, so that is what a geometric sequence is. That is defined here. The only thing to really say is that we define it by taking one term, and if we divide it by the preceding term, we're going to get that common ratio R. Now then, let's see if we can derive some kind of formula for this. Where should we go? Over here, look. Okay, so let's think about a common term. Well, the first term would be U1 again, right? The second term would be that first term multiplied by the common ratio. The third term would be, well, the second term multiplied again by the common ratio. Well, that would be like having U1 R squared. The fourth term would be U1 R cubed, and so on and so on and so on. So if I wanted to find a general term, well, all of those all have a U1 at the start, and they all have R to the power of something. And that power, that exponent, is 1 less than the term number, okay? Because here, look, that was the fourth term. Well, we have a power of 3. This is the third term. This is the power of 2. So it's going to be that term number minus 1. And this is your general formula for a geometric sequence. And we're going to be using that a lot in the upcoming video. Let's take a quick look now how we can use it, okay? So we'll write it here, look, on the side. Un equals U1 times R to the n minus 1, just to make that explicit. Okay, so part A, let's show the sequence is geometric. Well, 4 divided by 8 equals a half. 2 divided by 4 is equal to a half. 1 divided by 2, well, that is a half, okay. A half divided by 1, that's a half too. So this is geometric. We can say that we have a common ratio we've just found that is a half. Let's write hence geometric. Okay, part B, find the general term. So we have got that U1 is 8, and we have just found out that that R value is a half. So for us, UN is going to be equal to 8 multiplied by a half to the n minus 1. There's our formula. Okay, C. Hence, find the 12th term as a fraction. Okay, so that means that n is 12. If we want to find that 12th term. So popping this into the formula, U12 is going to be 8 multiplied by a half to the power of 11, right? Okay, so how can we do this quickly? I guess, well, 8 is 2 cubed, and we've got a half is 2 to the minus 1, so we've got 2 to the minus 11. So overall, we've got 2 to the minus 8. That 2 to the 8 is 256. So we've got 1 over 256 as our answer. There we go. All right, so that's how you could perhaps do that without a calculator. Right, hopefully this has introduced the idea of a geometric sequence. You understand what the common ratio means. You've got that general formula, and we can start to apply it to some more complex questions in the next